Alright, now we're on to it's 2.5, we're on to the power rule, and this is going to make your life so much easier. Remember when we did the limit as h approaches 0, and then you did f of x plus h minus f of x all over h to find the derivative? Well, you don't have to do this anymore. You don't have to do this long math. There's a rule for it that we can just follow, and it gives us the answer easily. It's called the power rule. And pretty much if you have a function that's x to the n power, the derivative of this function will be n times x to the n minus 1. This may look confusing, but it's really not. I'll give you a few examples. Let's say you have x cubed, right? That's the x to the n version. Then you do 3 times x to the third minus 1, which would be 3x squared. Another example, if you have x to the 37th, which is x to the n, you can do 37 times x to the 37 minus 1, so it'd be 37 times x to the 36th. That's the simple thing of the power rule. It's very easy. That's the basic explanation of the power rule is what I meant. There's some tricky ones, but we'll go to those. Alright, I put up some practice problems. The first 3 should be pretty easy, but the bottom 2 might be slightly confusing. Because with the power rule, you have to be careful with the exponential rules that you learned before. But just try these problems and we'll get to them. So we'll start off with the 1 over x. This can be written as x to the negative first, and then you just do the power rule. Negative 1 times x to the negative 1 minus 1, which is negative 2. And then negative 1 over x squared is the final answer. Now with a root x, this can be written as x to the 1 over 2, or x to the 1/2, sorry. And then you can do the power rule, 1/2 times x to the 1/2 minus 1, which is just negative 1/2. And then the final answer is 1 over 2 times root x. And then we have x to the third power, but it's to the 7th root, which can be rewritten as x to the 3/7. And then you just do the power rule, 3/7 times x to the 3/7 minus 1, which is negative 4/7. And then you can just rewrite it, 3 divided by 7 times x to the 4/7. Now these bottom 2, you have to use exponential rules, so let me just clear this out and make some more room real quick. Alright, so for this one, we can bring the root x to the top, so it'd be x times x to the negative 1/2, and then we can multiply them, and when you're multiplying powers you can add them, so this becomes x to the 1/2. Then you can just use the power rule. This would be 1/2 times x to the negative 1/2, which we've done before, and be 1 over 2 root x. But for this one I wrote f prime of 7, so we're trying to find the rate of change at x equals 7. So we just plug in 7 at the end, which would be 1 over 2 root 7. And you usually don't have to evaluate it. That's your answer. Now for this one, it's very similar. So we just do x squared. And this is x to the 5th power, but it's to the 6th root. So it's to the 5/6. X to the 5/6. Multiply. And then we get x to the 17/6. And then we can use the power rule. 17 over 6 times x to the 11/6, I believe. And then we just simplify 17x to the 11/6 all over 6. And that's our final answer. And that's pretty much how you do the power rule. Oh, so what I forgot to include real quick, I was looking back, is that if you have just x, this is x to the first technically, so you can still use the power rule, and this becomes x to the 0 times 1, which is just 1. Just letting you know. That's pretty much it. Now you won't have to use that formula, the limit as h approaches 0, 1, for the most part. You can't do division or multiplication yet. That's a quotient rule and product rule. You'll do those later. But yeah, that's pretty much it for 2.5.